Right, I am just going through the examples in the book, so I haven't had time to think about anything else, so apologies. So the next one along, but do consult your textbook as well if you want to. They've written this out really wordily, but the projectile is being projected from a height of 42.5 metres at an angle theta to the horizontal. Time of flight is 5 seconds and tan theta is 4/3. I would be tempted literally straight away to just think, well, there's theta, tan theta opposite over adjacent. It's a 3, 4, 5 triangle again. Never would have guessed that. And so cos theta is adjacent over hypotenuse and sine theta is opposite over hypotenuse. And then you've just got them there. You can assume you're going to use those, I think, within a projectiles question. First thing to show that V is equal to 20. Most of my information is vertical. Well, the only bit of information is vertical. So I'm going to resolve vertically. So resolving vertically, upwards positive. I would just be consistent with that right the way through. And so the displacement S is going to be minus 42.5 when it comes down to here. Time of flight is equal to 5. Acceleration is downwards, so negative 9.8. And we want the initial velocity, but it's called V, so we want U. But yeah, that's fine. I'll do it that way around. So the thing we actually know, maybe we'll do it like this actually. We actually know that U, so we're resolving vertically, is equal to V sine theta, because you want the opposite to theta. So V sine theta is U, and sine theta is 4/5. So U is equal to 4/5 of V, and it's V that we're trying to find. And so we need to use S equals UT plus a half AT squared. So substituting in, negative 42.5 is equal to U, which is 4/5 of V. I wish I'd called it something else really, it's a bit confusing. T is 5 plus a half A, which is minus 4.9 times 5 squared, which is 25. That gives you, when you just add this on, multiply it out, 80 is equal to 4V, and so V is equal to 20 metres per second. So just one that doesn't start from the origin, really. And then the next bit of the question was just to find x, which was this horizontal distance, which really is nice and straightforward. So resolving horizontally, there's not a lot you can do because the acceleration is 0. So A is 0, T is 5, U is equal to V cos theta. So we want the adjacent. V is 20 and cos theta is 3/5. And so U horizontally is 12. And we want S. So we want the horizontal displacement. And so again, it's S equals UT plus a half AT squared. The acceleration is 0. So S is just equal to speed times time. So 12 times 5, which is equal to 60 metres. So that's that. Another one. Reeling them out. A particle is projected from the origin with speed 35 metres per second at an angle of elevation of 30 degrees. Find the length of time for which the particle is 15 metres or more above the origin or above projection. So for this one, I would draw a diagram personally, but it just orders my thinking a bit. So 30 degrees, don't worry how accurate it is too much. 35 meters per second. So the projectile is doing something like that, and we want to know the length of time, which is above 15 meters. I get to use different colours, exciting. So we want the length of time, it's above 15 meters. So again, we're kind of interested in that vertical. So resolving vertically. I'm hoping you're not going to find these too bad. U is equal to 35 sine 30 to give you the opposite vertically. Sine of 30 is a half, so that gives you 17.5. So 17.5 vertically. A is negative 9.8. S is 15. So we can find the times where it's at 15. Then the length of time it's above 15 will be between the two. So that's kind of where we're going with this. And we're looking for T. So again, it's S equals UT plus a half AT squared. It's feeling a bit repetitive now. 15 is equal to 17.5 T minus 4.9 T squared. So you can pop that into your calculator, it's a quadratic. So 4.9 T squared minus 17.5 T plus 15 equals 0. That gives you T equals 10 over 7, or T equals 15 over 7. And just make sure you're answering the question being asked. So we want the length of time is 15 meters or more above the origin. And so the length of time um, 15 meters or more above O is equal to 15 sevenths minus 10 sevenths, which is equal to 5 sevenths of a second. I'm breaking my rules of rounding now, so that should really be to 2 sig fig. So 5 divided by 7 is 0.71 seconds. So don't go to too much accuracy in mechanics, especially when you've used G to 9.8.